Hello, I'm just going to give a quick update on the refurbishing of Roger's boat, our test boat, and the installation of the new rudder servo. I built the circuit up on Vera board, which is about the level of sophistication I normally apply. This plug here can be plugged in just to program it from the PC. That isn't normally used, and then it folds over like that into an IP68 box. This box weighs 640 grams, which is quite a lot more than a Savox brushless servo, which weighs 54 grams. On the other hand, this one is more waterproof. Hopefully stronger, more reliable, we hope. Whilst I was about it, I've included here a chip that measures the relative humidity inside the box and also the temperature, and it reports that back up the serial line from the Arduino. So we shall know if this starts leaking. So I made this wooden framework into which this box should fit neatly like that, and then I made this linkage to connect it to the rudder thusly. This is a stainless steel sealed bearing, and then we've got an IP68 connector here which connects this cable, which is outstandingly expensive and UV resistant and God knows what. I took a hammer to Roger's trolley and knocked out this piece of wood which was getting in the way of the rudder, because I wanted it to be able to go to the maximum. Well, I wanted it to be able to go to 72 degrees either side of the central. That's because the servo, every time it's powered up, it moves the rudder to plus 72 degrees and minus 72 degrees to calibrate itself, basically in order to get those opto switches to operate. I'd originally intended this to be plus and minus 70 degrees, but it turned out to be plus and minus 72 degrees by the time I'd made that opto disc in a more or less handmade manner. The other thing I've been doing is working out how to get this cable through the deck in a waterproof manner. So we have here a cable gland, an IP68 cable gland, and this is just a stainless steel plate that I have screwed with an amazing number of screws to the deck, using a bit of Hylamar underneath in the hope that that will be waterproof also. Then we're going to have an IP68 box here to which that cable plugs in with the autopilot in it and the GPS and the compass and so on. It's going to take its power from this little power bank, which is 5.2 milliampere hours and outputs exactly 5 volts. So that seems convenient for test purposes, obviously not sensible for the final boat. We're not actually planning to put solar panels on here at the moment. So that's where I've got to. I've got to wire up these components, fix them in place, and then we should be ready to do a test sail. I just want to have a bit of a moan about the IP68 waterproofing standard for electronic components. IP68 boxes have got a lot better in the last 20 years, and nowadays if you buy an IP68 rated box, it really will be watertight and gas tight. The same cannot be said for switches, which are often rated IP68 but will rust to non-functioning state within about a year if you leave them outside in the garden. And There are also problems with IP68 cable glands, and that's what I'm going to moan about right now. Here we have some IP68 cable glands that have been in my stock cupboard for 20 years, but they're still available from RS Components with the same stock number and I presume the same design. Here's one of them. It has an O-ring here such that if I mount it to a panel like that, there is a waterproof join between the cable gland and the panel, which is lovely. So what does it consist of? Well, there's a metal tube which is threaded on the outside, and into that fits a hard plastic tube like that. And inside, at the top, there are fingers for compressing this circumference, and fitted inside there is a rubber sleeve. And not sure if you can see this, but at the bottom on the inside here there is a little slot, so that when this rubber sleeve is put in there, it fits into that slot. And then we have a metal cap with a taper on the inside, so that if I do it up like that with a cable through here, it squashes the rubber onto the outside of the cable, which is nice. Now, I'm prepared to accept that this design properly grips the cable and makes a watertight join between the outside of the cable and the inside of this rubber sleeve. And I'm also prepared to accept that by screwing this thing up and pushing it down like that, the rubber sleeve at the bottom makes a watertight join with this plastic, so that any water that might go down the outside of the rubber sleeve and the inside of the plastic will not get through to this side. However, what about water that comes from the outside, from the environment, down these slots to this point here? What is to stop it flowing through between the outside of this plastic and the inside of this metal? The answer is nothing. There is no O-ring seal here, and none inside this metal tube. So my thought is that if I were to do this up, fit it with a cable, and then apply water under pressure from the outside, probably some of it would get through here and would then come into the interior of the box through this gap here. There should either be an O-ring seal here, or else maybe there should be a groove on the inside here with an O-ring in it, so that this slides in and is correctly sealed that way. I think what I will do before I assemble this is to put a thin layer of Hylamar, which is a non-setting gasket compound, around this plastic here, and just hope for the best. But to my mind, it's an example of the way people who design IP68 fittings and switches often don't really think the thing through to the end. I think the IP68 rating is sort of self-certified by manufacturers, so there's very little supervision of it, and it would be better, in my view, if it was a little bit more rigorous. However, we have to live with the world as it is, so that's what I'm going to do. End of moan.